Let's look at the sum rule of derivative. And here you can see two functions, fx and gx. And you will notice that the variable is x in both the cases. So how do we calculate the derivative of this? Although we already had some glimpse of this, we had already used this property, but I did not specifically tell that we call it sum rule. And there is nothing special about plus sign here. This can be plus or minus, so it will hold true for both. So you can see that both are functions of x. So you can think of them as a combined function, a single function of x, let's say p of x. So the way to differentiate it is that you calculate the derivative of fx with respect to x and gx with respect to x and add the signs depending on whether it's positive or negative. So why is it true? So we know that the first principle describes derivative as, let's say we will talk about in terms of px, then d of px over dx according to first principle will be a very small quantity h, px plus h. Take the value of px at a small amount to the right of x by h. H is very close to 0 and subtract the value of original. So this is the difference in p. So if this is the curve and you take px here, px plus h here, this is x plus h, this difference is h, and this difference is px plus h minus px divided by h. So this is the derivative from first principles. So px is itself px plus fx plus gx. So replace this with fx plus h plus gx plus h. This is the expansion of this term. So whatever is the variable here, the same variable for f and g. And now let's expand px. So px is fx plus gx. Minus here and this combined term plus, but we have removed that bracket, so everything becomes negative, divided by h. Now let's rearrange the terms. So we do fx plus h. So if we are adding 3-4 terms, the order does not matter in which order we add. Fx plus h, then minus fx. This is first term. And then second term is gx plus h minus gx. So we have just arranged the terms from third to second and second to third. And the combined denominator also you can split. And h tending towards 0 in both the cases. Now what is this first term? Fx plus h minus fx by h. This is dy dx of fx. What is the second term? This is dy dx of gx. So we see that this sum rule is correct, and it's very intuitive also. We had in fact used it a couple of times in our previous lectures on derivatives, but here I just wanted to make it explicit, and plus and minus both are equivalent here. So let's take a look at one example. So this is fx. Fx is here x cube. So let's write it in this form. We can do it immediately by looking at this also, but let's do it using this formula step by step. So fx is x cube. So we write x cube here, and then dy dx of gx is this term, 2x. And now we know dy dx of x cube is 3x square. Using the formula that we had seen in the previous video, this is also called power rule. I forgot to add the name here in the last video. So what we did, whatever was in the exponent, and there can be one constant also, just to make it more generic. So whatever it was in the power, we bring it forward. We multiply it with the constant. If nothing is constant, constant is 1. So Cn, then we decrement the power by 1. So this was the general rule. This is a special case of that. And this is power rule. So this will be 3 comes in the beginning as a multiplier. Then power of x is decreased by 1. X square from x cube. And what is the second term? The same thing. Power here is 1. We don't write 1, but implicitly it's 1. So 1 comes before, does not change anything to the constant. And power decrements by 1. So 2 x to the power 0. And anything raised to the power of 0 is 1. So this is the final result.